In the last video, we looked at an example of how to use confidence intervals to estimate a population proportion. And in this video, we'll be looking at confidence intervals in a more general sense. So in that last example that we did, we used a confidence interval to estimate the value of a population proportion, but you can also use confidence intervals to estimate other kinds of population parameters, such as a population mean or a population standard deviation. Population parameters are just quantitative characteristics of a population, and the most common population parameters would be a population proportion, P, a population mean, mu, or a population standard deviation, sigma. Usually population parameters are unknown because it is often difficult or impossible to study every individual in a population. And for this reason, researchers collect random samples to instead calculate a point estimate. Point estimates, or they're also called statistics, are quantitative characteristics of a sample. And the most common ones are the sample proportion, p hat, the sample mean, x bar, or the sample standard deviation, s. In that last example, the margin of error was calculated, and the margin of error indicates by how much the actual population parameter could be different, either higher or lower, from that point estimate. And confidence intervals combine point estimates with the margin of error. A confidence interval is an interval of values which you are highly confident, for example 95% confident, contains the true population parameter. By calculating a confidence interval, you can infer the best estimates for a population parameter. So they usually take this form. You'll have your point estimate minus the margin of error for the lower bound, and then the point estimate plus the margin of error for the upper bound. In the example we just did, it was p hat plus and minus margin of error. In the next section, you'll see this confidence interval, and this is with x bar, but it's the same pattern, x bar plus and minus the margin of error. This is an illustration of what the interval would look like. In the middle would be your point estimate. In this section, it would be the p hat. It's kind of like a guess, except it's better than a guess because it's based on a study. And then the point estimate plus and minus the margin of error would be the lower and upper boundaries of that interval. And the confidence interval would indicate that the population parameter, let's say p, is somewhere between those two numbers. It's somewhere in this range of numbers. Something else that was mentioned in the last video in the example was level of confidence. Margins of error and confidence intervals always depend on this level of confidence. The level of confidence is chosen by the researcher, and is typically 80%, 90%, 95%, 98%, 99%. There's a technical definition of confidence, and that technical definition is that if a confidence interval has, say, 95% confidence, that means that if many different samples are obtained, approximately 95% of confidence intervals from these samples would contain that population parameter. But you could also think of confidence in just the way it's used every day. Confidence gives you an assurance that your answer or that your conclusion is correct. And so if you have high confidence, then you have high assurance that your conclusions are correct.